Hypothalamus Artificial Intelligence, HI, is a knowledge-intensive company in advanced and complex mathematical modeling. Its main research focuses on the integration of traditional artificial intelligence, mainly supported by artificial neural nets, ANN, and the machine learning algorithms, based on support vector machines, SVM, with the large-scale mathematical programming principles. This is aimed at producing artificial brains, that is digital transformation driven by autonomous and intelligent algorithms in real time, in accordance with the era of Industry 4.0. HI introduces the products offered in the alliance OPTEX-GAMS. HI operates as a knowledge factory in highly complex mathematical modeling. Its objective is the monetization of its intellectual property, making win-win commercial alliances. For this reason, one of HI's main interests is to make joint ventures with GAMS business partners, and with GAMS to go to market. The solutions offered by HI can support the growth of startups, spin-off companies, or companies already created, to offer solutions to their end users, as part of the digital transformation of companies. OPTEX-GAMS is the computer platform developed by HI for general algebraic modeling systems, GAMS, users. As a GAMS business partner, HI has linked all its OPTEX's mathematical methodologies and technologies to the development of highly complex mathematical optimization models using GAMS language, to offer to the end user a total, automatic, integration between them. The video introduces the enterprise-wide optimization systems offered by HI GAMS. To see the general OPTEX-GAMS connectivity, the interested party can watch the video. OPTEX-GAMS Artificial Business Management. HI Enterprises-wide optimization systems. HI GAMS solutions are integrated into specialized enterprise-wide optimization systems, covering multiple industrial and socio-economic sectors. Subsequently, the description of the solutions offered for each sector is presented in a summarized manner. The table presents a brief description of the solutions offered by HI, using GAMS programs. Industrial enterprise-wide optimization. Industrial value chains can be conceived as multiple links that work as the union of two chains, supply and demand. The supply chain is associated with production activities, while the demand is associated with the business. These chains cannot be thought of as mutually exclusive, as the border that could divide is fuzzy. What is clear is that they are complementary and that their union affect all the value chain. HI models mainly support two types of industrial planning activities. SANDOP, sales and operations planning activities that are carried out periodically, usually every month or every week, to coordinate the selling products with production activities. IBP, integrated business planning, activities that are carried out periodically, usually every 6 months or every year, and aim to perform integrated value chain of the organization planning. The solutions offered by HI to the general industrial sector are based on the integration of following groups of solutions. HI DCO, demand chain optimization. HI SCO, industrial supply chain optimization. HI bio-industrial supply chain optimization, and HI HRA, human resources analytics. S&OP may be constructed based on 8 groups of solutions or systems: production, energy, maintenance, distribution, sourcing, human resources, financial, and sales and marketing. HI view the systems as groups of equations that must be included in the S&OP mathematical problem depends on many factors, so that there is no revealed truth regarding what the S&OP problem is. Since the equations are defined in a database, the configuration of a problem is limited to selecting from the equation store which are the ones that the modeler wants to consider in the model. Sales and operation and financial modeling. The connection of financial models with operating models provides, as a minimum gain, the automatic and coherent generation of the financial statements. As a substantial improvement of the decision-making process, the linking of the financial model with the supply chain models allows to optimize cash flow and treasury management, working capital, tax management, dividends, repatriation of capital, payment of liabilities, the capital and capital structure, transfer pricing, and the analysis of corporate financial risk. Production and energy services planning. Models oriented to the integration of the system of production of goods, transformation of matter, with the systems of production of industrial services, transformation of energy. Mathematical models optimize the production process including industrial service plants at the tactical level. The union of the SAND-OP and ISO models allows companies to link to the production plans the management of environmental restrictions, the management of the carbon footprint, the negotiation of energy in the different markets, and the minimization of production costs through the explicit inclusion of energy costs. Its use includes the design of new electricity supply networks, integrated production energy planning, emission control, material blending, and fuel blending. Multi-echelon dynamic inventory. Non-anticipatory stochastic programming models, based on random scenarios, to determine the optimal inventory management policies in a multi-linked distribution chain. The objective function is to minimize the sum of the expected costs of storage, purchase, transport, and loss demand, considering spatial location of distribution centers, location and demand of end customers, distribution center capacity, purchase cost, availability of working capital. It includes financial risk control concepts. The definition of inventory management policies focus on minimum inventories of raw materials and finished products and quantities to be ordered throughout all the facilities of the supply chain that must meet the orders of the end customer. It is applicable for the inventory management of spare parts. Global sourcing optimization. The main result of HYGSU are the purchase orders must be issued by the organization. For this, a detailed modeling of all the negotiation and purchase processes is carried out, mainly of imported raw materials. It considers in detail the Incoterms for trade between large regions and the special tariff regimes for the promotion of exports from imported raw materials. HYGSU considers conditions of shipment of goods, Incoterms, delivery time, delivery route, delivery times, cargo consolidation, multiple supplier offerings, regulation of each country, production scheduling. HYSCED aims to produce a detailed schedule, by hour, shifts or half shifts, the operations to be performed on each production line, cell, and machine, including the technical specifications of production, like temperature, speed. Production goals are pre-established, which implies that the first objective is the generation of a feasible production program that ensures compliance with the production goals established by the tactical level. When there are multiple factories, the planning scheduling process involves two steps: aggregate planning using the S&OP model, and detailed production scheduling using individualized SCED models for each factory. Maintenance planning and scheduling. Optimization models of the asset maintenance process, to have a safe and reliable operation of the production system to improve relevant operational aspects such as functionality, safety, plant productivity and profitability of the industrial operations. The model proposes maintenance start and end dates for each asset. Mathematical models follow the methodological principles of PHM, prognostic health management. Available to promise in distribution activities. The function called ATP, available to promise, is oriented to the assignment of products to the orders of the final customers and to the delivery trips of said products. High ATP allocate product available in distribution centers, and in short-term production plans to firm or potential orders that expire in the short term, additionally also supports planning of vehicles of cargo and its routing. Industrial Decision Support System. The architecture of a production DSS in an organization is presented below. It is made up of 8 models and the diagram describes the data flow between models. Traditionally these models are run with a certain frequency, daily, weekly, bi-weekly, monthly, and the implementation of the decisions depends on the professionals who must validate the results. In some cases, this validation is automatic. The artificial hypothalamus is the evolution of DSS under the Industry 4.0 revolution, and it is the integration of the methodologies of artificial intelligence and mathematical programming. The image shows some examples of screenshots of solutions implemented with the methodologies and technologies managed by HI. Related with enterprise-wide optimization. Optimization of agro-industrial supply chains. HI Bio consistently meets all solutions developed by HI in different areas of application of mathematical optimization models, aimed at the planning and the scheduling of operations to synchronize the primary link, in the farms, with the industrial link, in the factories, of an agro-industrial supply chain, to produce food from the vegetable and the animal raw materials that are developed on the farms. The value chain covers from breeding farms, the transformation of the benefited animals into commercial products to the distribution of such products to different customers in multiple markets. Geospatially, it is made up of networks of farms, slaughterhouses, industrial plants, distribution centers and points of sale. Mathematical models seek optimize the management of the network of supply chains of vegetable raw materials, for example, corn, soybeans, fodder, and animal raw materials, for example, poultry, pigs, cattle, fish. Optimize the planning and scheduling of the industrial operations in the factories, for example, feed production, meat processing, and minimizing costs to achieve considerable savings in the process and increase the profitability of the business. Planting and harvest planning. Models aimed at optimizing decision-making processes related to planting planning and harvest scheduling. Stochastic programming models that include hydroclimatic systematic scenario and financial risk management. Planning livestock farms. The main objective of the model is the planning the optimal operation of a dairy farm. It is a mathematical optimization model that considers the integral process of cow growth, pregnancy cycle and milk production, forage cycle, supply of food, nutrients, cost of production, and sale of milk in a market with dynamic demand and prices. The results are pregnancy cycle of cows, for each animal, forage planting scheduling, rotation of cattle lots in paddocks. Balanced food replenishment. Models aimed at optimizing the planning and scheduling of the supply to the network of farms of balanced feed, or fertilizers for the case of vegetable crops, from the industrial plants that produce them. This process considers the age distribution of living things on different farms, since age determines the type of nutrients they require. The process includes transportation costs and the capabilities of the vehicles to be used in the process. At the tactical level, the models determine consumption goals for feed, or fertilizer. At the operational level, the models establish in detail the transport services that are required. Animals and vegetables collection. Models aimed at optimizing the collection of agro-industrial products and their allocation to commercial commitments, orders and/or bilateral contracts, considering the capacity and availability contracts signed with transport/shipping companies, and the owned vehicle fleet and the enlistment capacities of said products. Bio-industrial available to promise. The problem of planning the allocation of live animals to commercial commitments is to find the number of whole animals and animals per piece that are required to meet demand and reduce costs. The questions to be solved are: when should the whole animal be used/bought/sold? When to cut it into pieces? When to use/buy/sell the parts? Which commercial orders should I assign the whole animals and parts? Which animals from which farm should go to a certain processing plant? Bio-industrial available to promise during demand super peak periods. The problem of assigning live animals to commercial commitments during periods of exceptional peak demand, usually associated with special holidays such as Thanksgiving, Christmas holidays, involves the coordination of multiple decisions to achieve cost minimization to maximize the profitability of sales during the peak season. It involves integrated planning that must cover several fronts. Farm planning, inventory management policies, reconfiguration of the distribution network, product transport planning, and reverse logistics planning, expected, biomass energy planning and scheduling, design and implementation of mathematical models that integrate the bioenergy process with the integrated management of one or more farms in such a way that the economic, social and environmental sustainability of agricultural production is integrated and optimized. The energy produced by the conversion of energy crops, or animal manure, into biogas and/or biofertilizers should be considered, using anaerobic digestion technologies, crop allocation, and animal husbandry practices. In many cases, in a single farm it is not profitable to produce energy, which can change when considering the network of farms located in the same region.